right. Hello, everyone, and welcome to the stream. I hope everybody is doing well tonight. Next here, hello, welcome. Good to see you. So tonight on the roster, we are going to pick up where we left off last night and finish up the shadow mapping. I did figure out what the issue was. True to form, about 30 seconds after I stopped the stream, of course. So we'll go over that, as well as a few other tweaks I made, and we'll talk about a couple of other things we need to do regarding that. So before we jump into that, I just want to take a quick second and thank the supporters of this channel. They are starting with the partners, who are the highest tier of subscription over on Patreon and YouTube memberships. They are A.R. Slia, Gebi Bashir, and Gerbolis Inc. Thank you very much for your support. I'd also like to thank all the other supporters listed here on the screen. They are the other tiers of support on Patreon, YouTube memberships, and Twitch subscriptions. So thank you all very much for your support as well. I greatly appreciate it. Of course, none of this would be possible without each and every one of you viewers here. I really appreciate all of you guys, and I very much am glad that you guys are here. Of course, without you guys here anyway, none of this would exist, right? This project, I wouldn't be able to do this, right? So I appreciate the support from all of you guys. That all being said, this is a interactive stream, so it's designed to sort of interact with you guys. So if you guys see something on the screen, you want to talk about it, feel free to bring it up in chat, as long as it's relatively related to the channel, the topics that we're discussing. It's free discussion, right? So the aim here is to build a game engine from the ground up, almost completely from scratch. There are a couple of shortcuts that we took, but for the most part, we are building everything here from scratch. So with all that said, let's go ahead and dive into it. So, oh, Denise, hello, and Nivi, hello. Welcome to the stream. So, yesterday we were kind of in a predicament where the calculation for the shadow map wasn't quite working right. We were like 95% of the way there. At least that's what I was saying yesterday and thinking. And it turns out we were actually a lot closer than that. There was just a couple of small things that I had to actually add to get all of it working. So the main things that I had to add were actually in the vertex shaders. So I'll take a look at the PBR shader here. Let me get rid of this terminal, if I can spell exit right. This one too. How many terminals are open? Okay. So if we take a look at the vertex shader, we have here in this comment that Vulkan's y-axis is flipped and the z range is halved. And I had forgotten about this when I was sort of writing this with OpenGL in my head. I'd forgotten about this very, very, very important detail. And so because of this, we basically have what we're calling here a bias matrix, which essentially makes that transformation for both of these things that we require for this to show up correctly in Vulkan. So all we do is we have this predefined here, and then we work it into our multiplication down here, right? And that is basically to make sure that this light space fragment position is actually correct. So it was a combination between that and coming in here and flipping the y-axis here. And that was it. That was all we actually had to do. And I've got some other stuff in here that I added that I will explain in a bit, right? But before we do that, I want to point out a couple of other things that we did sort of off screen right before the stream, just to kind of bring everything up to speed so we wouldn't have to do it all on camera. Smudge, hello, welcome, good to see you. Drail, hi, I'm just starting your YouTube series on the Kohi engine. 155 videos is daunting, but I super appreciate how detailed it is so far. Well, first off, welcome to the stream. I see that you're a first-time chatter, so welcome. So yes, 155 videos is daunting for sure, but if you think about it, a game engine is a very large, complex piece of software, and there's lots to explain. So the Kohi engine series starts off as sort of a tutorial series, and it kind of morphs from that, right? I tried a few different video formats to kind of figure out what worked the best, And in the end, we decided that live streaming like this works the best, right? So eventually along the way, it does turn into a live stream. I think it was, where did that happen? I can't remember what episode number that was. Let me look it up real quick. It was around, I want to say it was around episode 100 or so. But I'm actually thinking it might have been sooner than that. Let's see. So, let's see. Well, it was at least back to 100. Looks like sooner than that, actually. Might have been like around episode 75 or something. Let's see, okay. Okay, so it looks like we started live streaming at episode 82. So, yeah. Hopefully I have your bearings in the code base by then. I think so. You know, a lot's changed since then, obviously. Because a lot of the concepts that we do throughout this, we sort of do in a learning-friendly format, and then we later go back and kind of refactor it into something that's more performant and organized, right? So there's a few things throughout the series that we try that didn't wind up working out, or that we had to change slightly. So, you know, things do change around, but as long as you know, are kind of working your way through the video series, all of it should make sense. So I hope that helps. Okay, so aside from this being flipped and whatnot, there were a couple of things in here that I had to add. First off, we added the same logic to the vertex shader for the terrain, right? So we have this bias matrix in here, and we multiply that in here. And then the fragment shader also received the same updates, right? With the reverse Y, and then the I think that was actually it, other than working it into the actual lighting, right? Which actually we had correct. So that was, let's see, where was it? It's further down here, I think, towards the end of this, right here. So we basically just multiply that shadow by the total reflectance, and that gives us our ambient, right? And I should say that's correct with an asterisk. Because we aren't taking in point lights into account when we're generating the shadow map. So that will be something that we'll have to tackle separately. In addition to that, we had to make a couple of small changes in the shader config files. So the, let's see, the shadow map shader config file, we changed the cull mode to front instead of none, because we actually want to use back-facing. So actually, I'm going to change this back to none for a second so that we can actually have an example of why I did this. And let's see, what else? There was a couple of small changes I had to make in the material system. So in the material system, we actually were never binding the directional light in the correct place. So we did have apply instance, and apply instance we had right in here, just like we're doing for the material shader, we were doing the directional light. So that's actually been removed out of here for the terrain, because the directional light is global in terrain. So we move that out of here into global. So in the apply global, we now have not only the light space for shadow mapping, but also the directional light. So that gets applied at the right time. So there's that. Let me think, what else? I don't think there was a whole heck of a lot else that I actually had to change. I think that was literally it to actually get this to work. So what I'm going to do is run this now, just to kind of show you guys what it looks like. And then we'll talk about some of the other adjustments and stuff that we need to make. So let me go ahead and run this. All right, and I'm gonna load up a scene. And we can see now that we have something, right, that resembles a properly shadowed scene. And there are some artifacts with this, and we'll talk about what some of those things are. And so, for one thing, you'll notice that we have, this car is probably a bad example. Let me go over here. You'll notice that we have some artifacts here within the top of this ceiling, right? You'll notice as I move, it's kind of jittery and flickery and stuff like that. A better example might be to look at the wall over here. How it's got these sort of lines running through it, right? And that's basically caused by the way the light is hitting the surface by default. And so let me pull up Paint. I actually still have this this graphic from last night. If I can get Windows to stop being weird. So basically what's happening here, and I'll go with a thicker line, is we have our surface, right? And we have our light coming down, right? All of our light rays. And basically what's happening is the light is hitting the surface kind of like this, right? So what we're seeing is we're seeing these little shadow striations in between the lit bits. And so one thing that we can do, there's two different ways to fix this. We can either add what's called a bias, which can move essentially the squiggly line up or down relative to the surface. Or we can fix this by actually turning off front face culling. Or turning on front face culling and only rendering back faces for the shadow pass. So we'll quickly go over the difference between those two. Let's see. How did you learn all of this? Like, how did you know what to create and all? I saw the series on YouTube and said you've made a few small engines. Yeah, so it was a combination of that, lots of research, lots of reading over the years. In fact, you're asking about a book on game dev. Let's see. For game engines, there is no better book than this one. This is Game Engine Architecture by Jason Gregory. He works at Naughty Dog. This is a fantastic book about learning about game engines, how they're structured. You can see I've got all kinds of crappy bookmarks in here. How they're structured, and things even all the way down to the hardware level are in here. Memory management, things like that. So this is a fantastic book. And then there's also Real-Time Rendering, which is a fantastic book. And this one's by a bunch of people, so I'm not going to list them off here. But if you search for Real-Time Rendering and look for this book cover, you'll see it. So I'll have to put those back neatly in a minute. But yeah, between that and just reading resources online, looking at game engine code, so looking at Unreal Source, looking at the first game engine I ever worked with was a game engine called Torque 3D back in the day, or Torque Game Engine. I looked through the source on that a lot back in the day. Just basically doing that and then trying to roll it on my own, right? Is there any drawbacks to doing only back faces like that? There must be. Yes, there are. So we'll talk about what that is too. Diamond, good evening. Welcome. BeamNG, yes, BeamNG. I remember when that was still in Torque. Did you get the shadows working? I did. Yeah. So I actually have it working, and I have some optimization / adjustments, and that's kind of what we're talking about now. So basically, we're winding up with this effect right now, where we're getting these, our light's hitting our surface kind of like this, and we're getting these striations. I forget what the term is, but we're basically getting, I think they call it shadow acne. Actually, is the term for it. It's still Torque? Really? I thought they switched off of it a couple years back or something. That's kind of awesome to know. So basically what I was talking about is there's two ways that we can resolve this shadow acne issue. There's a bias that we can use that will essentially shift this up this way, right? And get rid of those striations for us. And that has its own disadvantage, but it's the easiest to sort of talk about first. So we're going to do that. So let's go ahead and do that first. So in the fragment shader, I've got to do this on both. We have this bias here, and I've got it commented out, right? I'm going to use a value of like 0.05 as a bias. And so I'm going to do it there, and then I'm also going to do, let's see, the terrain shader fragment shader rather. So we're going to add in a bias here. Looks like I never disabled it, but that's fine. Okay, and so we'll run the engine again. Tim, and welcome to the stream. Good to see you. I should point out also, there was one other adjustment that I made that I should probably quickly talk about, because you'll notice the lighting is a lot brighter, right? Let me talk about that real quick. So if I open up the scene file, and we take a look at the directional light, we used to have 0 to 1 values here. And now these values are like 80, 80, 70 for RGB. That's because our PBR system is an energy-based system, and so there is no theoretical maximum how bright something can be. Basically, the higher the number, the more energy that light puts off, and the more energy gets, reflected back off the surface. So we've ramped these numbers up quite a lot on directional light and our point lights as well. So these are all essentially 100 base, which they're a little bit too strong, but it kind of makes my point, right? So now this looks like it's a really bright sunny day, which is exactly what we wanted. So if we go to a little bit closer, and I should point out the normals on this mesh on the outside are kind of screwed, so that's what these things are. So just ignore those. That's the mesh, not our system. So if we take a look at this now, we can see that shadow acne is gone, right? This isn't noisy anymore. It's just, it looks nice and smooth. And we still have some jagged issues here, and that's because of the relatively low resolution in the shadow map. We'll get to that as well. But one thing that we will wind up getting, let me see if I have a good example here. Let's see, is there anything... There's an effect that you get when you use a bias. I just gotta find a good example of it. Let's see, not that. I might not actually be able to find a good example of it. There's an effect that you get essentially called Peter panning when you use a bias, right? And that basically is when you are rendering... Let me see if the car maybe has one. When you're rendering something that does not have a lot of thick geometry on it, you can actually get light leaks. I'm not seeing any examples of this here, though. Oh, here we go. Here's an example. Okay, so you'll notice this roof comes right down on top of that wall, right? But yet, we have this strip of light that's leaking through this corner right here, right? This should be shaded, right? But yet we have this light that's leaking through. So this is one of the disadvantages to using that, right? It's an effect called Peter panning, right? It basically means that it looks like it's floating even though it's not. And so that is one of the reasons that we don't want to do that. Okay. So instead of using a bias, the better way to do this is to turn on front face culling. So if we go to, let me see here. Bat Laser, thank you for the follow. I appreciate that. Tammin, you reached a 5-stream streak. Awesome. Woohoo. Thank you for that. Appreciate it. Maybe around the corner of the building, outside, yeah. Shadows are working, yeah. You fell asleep on top of your PC last night and lost the end of the stream. Well, I mean, at least the VOD is there, right? All right, cool. Let's see. Matthew Wilson, over on YouTube. Hello. Just found your channel. Currently binging your videos, so thank you for that. I'm glad you're liking them. Love to see how C is used in an object-oriented way without objects. So we're not really doing too much object-oriented programming. There's some things that kind of border on it, but we're not really doing OOP in general. I mean, eventually we might do some. Like, there's a little bit of a touch on it in the UI system, but that's pretty much it. Super interested in engine development, so your series is amazing. Awesome. Well, welcome. I'm glad that you're enjoying the series so far. Very cool. All right. So in our terrain shadow map config, we're going to set this to front, right? So we cull front faces, and we're going to do the same thing for the shadow map pass. So we're going to set that to front. And we're going to go into the fragment shaders of the PBR shader. And I'm going to set this bias to 0. And the reason I'm doing this is because we're eventually going to make this configurable with like dials and switches and stuff. So I want these to be here, whether or not we're using them. So we'll set that bias to 0, and then we'll set this one's bias. Whoops, that's the wrong one. Where is the... Here we go. We'll set this one's bias to 0 as well. And I think that's all I need to do. So I can actually relaunch this. Right, and it still looks good, right? No shadow acne. But now we don't have those light leaks, those annoying light leaks, right? It actually acts like it's supposed to, right? And the reason for that is because if you think about it, you know, shadows technically can be cast from the back face of an object, not the front face. And so when you have thick geometry like that, you can get away with that. The downfall to that is, and there is, you know, benefits and drawbacks to everything, is if you have just a flat planar surface that only has a front face, that's going to get cold and not cast a shadow. So, for example, if I go under here, you'll see that we have like our terrain is sitting on top of our floor right here, right? And if I kind of go through that terrain, notice how it's not casting a shadow, right? Because we only have a front face and we're culling that front face. So that's something you've got to keep in mind when you're building your geometry. Which method do you want to use? Do you want to use a bias, or do you want to use, you know, back face rendering only when you're actually trying to figure this stuff out? So, like I said, there's trade-offs to everything, right? Does everything have to be closed? Shadow acne is the word, yeah. So when you say does everything have to be closed, what do you mean by that? Like, there has to be a thickness, right? So see how this roof has a front face and a back face? That's why we're not getting light leaks on the inside. It doesn't have to be watertight, no. Nope. It just has to have a thickness, right? So if we go back to this drawing and if we have just a plain surface like this, right? That's got a front face only, and we have light coming down, right? Like this. And then we have, let's say, another surface here. This guy is going to be lit up because when we render this, when we render the shadow map, this surface doesn't get rendered, right? So what is actually, what we're doing now is we actually have geometry that has thickness, right? And it doesn't necessarily have to have these sides. Like, you could have this without the sides. The important thing is that there's a front face and a back face, right? And so what's going to happen here is the light is basically going to stop here. And so it'll see that back face and then stop, and it won't actually get down any further than that. So like this will go away. So I hope that makes sense. Are you using Windows 11 now? Yes, I am. I have been for quite a while. I have been for probably 2 years now. 2 years, maybe? Yeah, roughly. You've changed. Yeah, well, the thing is, I had to switch back to Windows from Linux because I could not get stable drivers. And I kept having my OBS just completely tank, and then it would take down the stream, and I can't have that, right? So I'm using Windows for a little bit, and then as soon as I can verify that it's stable again on Linux, I'll probably switch back to that. But, you know, it's good to go back and forth between the two just to make sure that it works across the board as well, right? So I'm kind of left without a choice there, unfortunately, but yeah, so our lighting is definitely looking a lot better, I think, right? So the next thing that we need to talk about is, you know, this is looking somewhat good, but like we have some artifacts here from our shadow map, because our shadow map in this case is a 2K shadow map, right? It's not very high resolution. So if you get right up on this, you'll see that there are several places where it just kind of is jagged edges like that, right? You can see it really well here, right? Because our shadow map's resolution is pretty low. And that's because we're taking just a single sample of that, and we're not really doing any filtering on it or anything like that. So if we go down here, it's really obvious right there. And so there's some ways that we can actually improve that a little bit, right? If we look at this car thing out here, it's really obvious on the side of this car, right? And so what we're going to do is we are going to activate a little snippet in here that does some filtering. And this is called percentage closer filtering. And so essentially what this does is it replaces this section of our logic right here. Actually, just this section, where we're just taking a straight sample off of the depth map and then comparing it against our fragment position and saying which is greater or less, right? So if we comment out this guy, we uncomment this guy, it accomplishes relatively the same thing, but smooths it out a little bit for us. So what we have here is we're basically taking a total of 9 samples, and starting at the center pixel, and then we're just kind of going out a pixel or a texel into the texture map. So we get the size of each texel by looking at the texture size and then doing 1.0 divided by that. And then we go from -1 to 1 on the x-axis, same on the y-axis. And then we take a depth sample of that. And we say, hey, the shadow projected depth, we do the same calculation that we did up here. Same exact thing, right? Only in this case, we did switch these back, right? Because this shadow is now an accumulator. So it starts off at 0, accumulates the value from all those 9 samples. Then we divide that by 9, and then we invert it by saying 1.0 minus shadow, right? What that gives us is a nicely blended result. So what I'm going to do is I'm only going to make this change in the terrain shader, and we're going to run again. Convolution, yeah, kind of like that. Oh, I just realized ads. Missed the ads. So those of you over on the YouTube side, I know you guys don't get served ads quite as often, but on the Twitch side there is a timer that goes off, and I missed it by about 30 seconds this time. So I'd like to pause the stream for that 90 seconds while ads are running, and we only have about 20 seconds left now, so sorry about that. I'll just quickly review everything that I said in the last 30 seconds. But yeah. All right, so we got about 4 seconds left. Tam, and you actually brought up a good point of something I forgot to mention as well. Yes. So there we go. Ads are dead. Wait a minute. No, they're not dead. It actually has a minute to go. Twitch, for some reason, gave me the ad message early. Well, that's annoying. All right, so we have about a minute left. I'll have to watch that more closely. Yeah, your ad started now. Yep. Sorry about that. So those of you over on the YouTube side, just bear with me for a minute. It's got about 50 seconds left, and then we'll get back to it. I just don't want anybody to miss anything. So we got about 30 seconds left, and then we can get back to it. And there's a couple comments I'm going to get to as well. Got about 20 seconds, and we'll be good to go. All right. 5, 4, 3, 2, 1, and now ads are actually dead. All right. Retro Ryu, 3 a.m. here, and I made it to your live for the first time. Love the series. Awesome. Well, welcome. I know it's late there, so I appreciate you staying up to see the live stream. And welcome. Okay. So yeah, I was completely off on ad timers there. So sorry about that. I will try to watch it more closely next time. Okay. So let's see. Does this change anything on the main rendering side or just the shadow map rendering? So most of the changes, there are some changes within the sort of main rendering side. I think that the shadow map side I actually had mostly right, believe it or not. So yes, this function here is like convolution. So yes. So is this weighted equally, or is there a viability weight to the samples with a Gaussian? No, it's not anything that fancy at all. It's literally just an average. That's all it is. It's unweighted. Oh, you mean the backface stuff? Yeah, so the backface stuff is only for the shadow map passes. So the terrain shadow map and the PBR, or the mesh shadow map shaders. Those are the only ones that render backface. The normal pipeline doesn't change. No, I meant, is it possible to do a Gaussian, and is that viable? You could, but it would probably be more expensive, right? And we're going to look at other filtering methods aside from this. It's just, this is kind of where we're going for right now, because we want to do other things with this as well that will help with this. But this is just one method of filtering that gives us a lot better of a result, right? So I have this running up here. I'll load. And I've only made this change in the terrain shader. And I did that so that we can compare the difference. So if I fly in here, I should probably change my spawn point. If I fly in here and look specifically right here, we could see how much better that looks already on the terrain than it does on this sort of static mesh, right? It's a lot more smoothed out, right? It's a lot cleaner looking. So you know, if we make that change in both places, we'll suddenly have a much nicer. And I need to resolve these things too. If we make that change in both places, we'll have a much nicer looking system. So if we go to the fragment shader for PBR, I'm going to shut this off. And this is just a copy of the same function. And run again. And now we'll actually go and look at the car, because that's a little bit better of an example. Without moving anything or whatnot, we can actually see that all those artifacts that we had sort of on the side of the car are gone. And so if we look at the car itself, we can see that the filtering on the shadow map is taking place. And it's not perfect yet. There are many other ways that we can actually filter this, but this one right now is pretty dang good, right? And I think it looks pretty decent. In fact, if I go ahead and grab this and rotate it, even when it's rotating around, it looks pretty decent, right? There are still some artifacts that you'll get at certain angles, but overall, you know, I think it looks a heck of a lot better than the old lighting system, right? Why does it already look like there's some kind of filter? Because we just added it, right? So that's that filtering that's there is this percentage closer filtering. That's what we just turned on. So yeah, that's literally the filtering, right? And all that's doing is just taking more samples of the texture. Okay, so Tammin actually brought up a good question. Oh, you meant beforehand. I mean, it wasn't, though. It was just kind of... It was being averaged out because of the angle that it was being projected and stuff. So there wasn't really any... there wasn't really any filtering other than the linear filtering that's done by the sampler. So maybe that's what you were saying. Like, it wasn't square. Yeah, yeah. So it was probably the linear interpolation from the sampler itself. If I had that on nearest neighbor, it probably wouldn't have done that. All right. So Tammin actually brought up a really good point. He asked, are you using the texture wrap mode as border because the edges of the textures, you have to account for that? Yes. So actually, I shouldn't have closed this. So obviously, if we have a... Do I still have RenderDoc open? You know what? Let me open this with RenderDoc. All right, so... This will help me... Whoops. This will help me explain a little bit better. All right, so I'm going to load this up. And I'll take a capture. And I guess I can just leave that running for now. So if we take a look at the shadow map itself, and I can do that really quickly by just going into the render pass, selecting one of these things, going to texture viewer, and then inputs. And here we are, right? So I also adjusted the angle of the light to give us a little bit better, lighting, right? So now it's kind of more over top a little bit. And so this is what our depth map looks like currently. Looks like I might have forgotten to turn the terrain on. Not that it really matters because there's not anything below it, but regardless, okay, so this is the angle that it's looking at. And so when we apply this texture map to the scene, this shadow map to the scene, these are the limits of our shadow information. And so what I mean by that is if we go outside of that, within the actual physical space, right? So if I grab this car, for example, see how there's a shadow under it right now? If I translate that over this way, once we leave the area where that texture map ends, notice that the shadow goes away, right? Now, that is basically what's happening there is something called oversampling, and it's what Tammin was alluding to. So, yeah, the validation errors, I gotta fix those. It's because I'm not cleaning up stuff when I'm shutting down. And so, basically what's happening is you're reaching the edge of this and it goes, well, I don't have any more shadow information. And so depending on what the, you go to, I think it was here and then here, depending on what the repeat UVW mode is, it'll act a different way. So most of these are set to repeat, just to repeat the texture. But we are actually using clamp border on this with a white texture. And so the white texture basically means we are not in shadow. By default, before this was black which would have meant that anything outside that border would have been shaded as if it was in shadow, which you don't want. And so generally, the way that you set that up is you set up a clamp on the texture with white as the background, and that is done in here. When we add border color to our sampler, right? And this isn't actually something that's configurable at the moment. We just kind of do it across the board. But only if you're using the clamp mode or the repeat mode of clamp border do you actually get this. And so that's how we're tackling the oversampling problem. So Tammin, I hope that answers your question. Okay. Hi, I wonder if there are plans for networking. Yes, there are plans. It's actually in the roadmap. I forget exactly where I put it in here, but it's in here somewhere. There it is right there. Right? And realistically, that probably will come later. After things like the physics system, right? And after things like skeletal animation and timeline system, right? Some of these other things will probably come into play before we do networking. Because I know the first few games that I plan on making with this are not going to be networked. So I was actually asking because of PCF possibly reading outside of the texture. I think it would just sample it as white. That's the way that it should work, right? So if it goes outside the texture bounds, it should just sample it as white and cut off. We can validate that real quick. I'm pretty sure that's what it's going to do. And I'm thinking we'll actually still get a weighted average result, or not weighted, unweighted average result rather. Right. So if I grab this guy and move him over here to the edge. Yeah. So basically just acts as if the shadow information just ended, right? Yep, it's accumulating with ones, exactly. Will you implement following shadow maps? So, do you mean like shadow maps that follow you with the camera? Because if that's what you mean, then yes. I don't know if we'll get to that tonight or not, but yeah, that is obviously... we need that to work. To solve this, would you just move the camera? To solve this, would you just move the camera that is from the lights view based on where your camera is? Yeah, exactly. So essentially what we have to figure out in order to make that work properly is, first of all, we have to enable frustum culling on the light itself, right? So we take that that projection matrix that we're using to actually render to the depth texture, and we'll actually use that to create a frustum, and then we'll say, okay, everything that is in that frustum needs to be everything that's within view of this camera. So we take the frustum from our view camera, and we say, okay, what's all the stuff that's inside of that? And then we say, okay, shadow map, you need to fit this. And obviously, when you look out over a cliff or something like that, that's going to be a large space. So cascading shadow maps are also going to be a thing. Honestly, for some projects, a static position shadow map could be better. Yeah, it could be. Like if you're running a small renderer or something, yeah, you could absolutely do it statically. And so what I might do is have that be optional as to whether you want it to follow the camera around or you don't. Because right now we basically already have the don't follow the camera around logic in place, right? And so, yeah, basically all we would do is just move the shadow map around. And then as you move away, ideally the shadows in the distance would sort of fall off once they exceed the range, right? So yeah, those are all things that we're going to have to add. But yes, this is the first step with that. You're really enjoying the series. Well, thank you, and I'm glad you're enjoying it. Do you do engine development as a day job? Not anymore. No. I did for almost 5 years, though. But yeah, not anymore. I got kind of tired of working long weeks all the time. So yeah, I don't do it as my day job anymore. There's more money elsewhere, quite frankly. And so that's what I do. All right. So let's see. What else did I want to talk about? I guess we should probably look into getting rid of these validation errors, of which there are quite a few. So these are... I think these are all just stuff not being destroyed. Sampler, sampler, sampler. These are probably from... Yep, the shadow map pass. Yep, shadow map pass, shadow map pass. Okay, yeah, it's all shadow map pass stuff, actually. So that shouldn't be too bad, actually. All right. Let me relaunch Vim because it's been open for a while. Okay, so let's go here and we really need to go into destroy. So let's see, what is this all looking for? It's probably just the images that need to be destroyed. Probably these guys. So where are we actually saving those? Are we just like creating them and then not? So we're creating those, but okay, so they're depth textures. I think if we just loop through these, we should be fine. So actually, I'm just going to do this and go to here before we destroy the extended data. We don't need those. Do we not have... We don't have internal data, so let me grab that. And I'm too lazy to type it, so I'm just going to do this. Okay. I don't think I need extended data, but we'll see. All right, so let's close that. All right, so instead of this, what we're gonna do is we're gonna say let's see, we should have texture. Do we not have a texture destroy? Can't be. We have a release, but that's from the texture system with textures that have been added to the system. These are not. All we did was create a writable texture. I guess we have to send it through the renderer, which is fine. So put that there. Send that to the renderer to be destroyed. That should clean up all the resources we need for that. So we need to do that for the color texture. And depth texture. And then obviously we need to clean up those arrays, right? So we'll do internal data, color textures, size of, texture pointer times attachment counts, and memory tag array. And we'll do the same thing for depth textures, so we don't leak that. I think that should actually take care of the view, the image, and the memory. Why did you pick C? Language simplicity. It's preference, really. I like C much better than C++. It's a much simpler language. And also, it compiles faster. So, yeah. What do you do as a day job, if you don't mind me asking? So right now, it's web development, but I still am working with a 3D renderer that's WebGL based, soon to be WebGPU based. So I still kind of do work with this stuff during the day, but it's also a web app that kind of surrounds that stuff. But yeah, it's all web-based stuff. Oh, unused extended data. Yeah, I didn't think I was going to need that. I don't think there was anything in there that I needed to clean up either. How's WebGPU? Still very, very new. And it's still not widely available either. So it's very much a learning exercise, right? It's kind of like learning Vulkan all over again, which a lot of the concepts actually translate over, but it has its fair share of annoyances as well. There's still a lot that I'm figuring out with it. All right, so we should be able to load this up, and then looks like, all right, we got most of them, I think. Looks like we didn't get them all. Oh, we didn't get rid of the samplers, right? We got rid of the images, but not the samplers. So we have the depth texture sampler. Wait, is it bleating about the same one? No, there's two in here. Oh, right. One for the terrain and one for the static meshes. Okay, that makes sense. And then the other two are shadow pass, text map sampler. I feel like these are kind of duplicated, but all of them have different addresses, so I guess they aren't. All right, what did we create at the top of this? In load resources. Oh, it's all of this stuff. We have to release all of this stuff. That's why. Okay. So viewport, I don't think actually has anything in it that we need to get rid of. Okay. So once we've done those, we need to actually do this should say destroy the attachments, one per frame. Okay. So this is going to be texture map resources release default color map. And I think that is return type void, so there's no need for this stuff. Right. And this is actually going to be the same thing. release. And then I think, oops. I think for this one, what does this want? Just the shader and an instance ID. So just that. We don't need this. And then we don't need this. We don't need this or this. Right. Okay. That should cover the 4 errors that we are getting. Compile faster nonsense. Look at the Unreal solution. It needs a cluster of PCs. Yeah, exactly. Yeah. Last time I did an Unreal compile, I think it took like 45 minutes from scratch or something like that. It was insane. Can you explain how the whole validation layers thing works? Sorry if it's off topic. So it's not off topic at all, actually. It looks like Taman actually kind of already started it. So graphics APIs have these optional libraries that sort of ship alongside them of logic that essentially looks at the input that you give it and tries to validate that it's correct. So the whole idea behind Vulkan is it's designed to not include that stuff by default, to be as thin as possible between you and the hardware. And so generally speaking, when you're doing a debug build, you would include validator logic, and when you're doing a release build, you would not include that to get more performance out of it. And so the validation layers are basically just that. They're validating the inputs that you're including into your from your application into the API are valid, right? Catch API misuses, synchronization issues, memory management problems. Yeah, and they don't catch everything though. Sometimes stuff will still segfault, and you have to actually debug into that why, as to why. They're definitely not perfect, but they have saved my butt a lot of times. How they work, what they are, like, do you have to link another DLL? So no, it's generally an extension. So, and then your actual Vulkan SDK setup will indicate how to load that. So the short half of it is most of them these days are actually, I think the debug one is back end. Oh, I'm in the H file. What a dingus. Why can't I find debug? So this right here is an extension name that we basically pass in when we're creating the Vulkan instance. And this is essentially what loads up a lot of those utilities. So if I go into this, it's VKEXT debug utils. So if I go on, where'd my browser go? Come back. Here's one. VK debug utils extension. Right, there's a man page on it on all the stuff that it gives you, right? And so it's basically another DLL that gets loaded automatically by Vulkan's loader for you. And there's a whole like config and setup in the Vulkan SDK that kind of takes care of this stuff for you. You don't have to link with anything else. You don't have to manually load anything else. At least not anymore. With Vulkan 1.0 you did. The only thing is sometimes you'll have to load function pointers to this stuff. So like that is actually what I was doing. So like this user callback right here for debug create info. You have to load these guys right here, right? So you have to use the vk get instance proc address, and then the name of the actual function you want to load, assign that to a function pointer, and then you can call it, right? This used to be the way that you had to do everything in Vulkan. You don't necessarily have to do that anymore. So it's loaded just like any other extension. Yep, exactly. When they don't catch the error, generally it's a device lost. Yes, but not always. I've had seg faults too, in the validation layers, which is really annoying. Yeah, no problem. I hope that made sense. Moving around in insert mode. Yeah, you know, sometimes I can't break old habits. I will say I've not been using Vim for all that long. I've only really been using it for part of this year, like full time, so there's still stuff I do wrong with it. We got ads. Just breaking the stream for a second, just so that nobody misses content while ads are going. For DirectX 12, you just have to use a special COM interface. Ew. To enable debug layers. COM interfaces. Fun. I can't wait for that. I haven't even thought about that. That's a good point. We got about 30 seconds left on ads, and then we'll be able to continue. Everything in DirectX 12 is COM though, yeah. Alright, ads are dead. The real-time rendering book you showed at the start, is it worth getting if you're like at a beginner, intermediate level? I think so, and I'll explain why. Because there are topics in there that are definitely going to go over your head. But that, in addition to the game engine architecture book, are books that you don't just read once and put them down. I've read through each one of those books probably a dozen times, cover to cover. And I use it as a reference all the time. So even if you don't understand everything in the book, there's undoubtedly going to be things in there you understand. And every time you read it, it's like a Vulkan spec, you'll learn something new. Like every time I read the Vulkan spec, I learn something new at a minimum. So, which edition of the game engine architecture? I think I have the 3rd edition. I don't know if there's a 4th edition out or not. But the 3rd edition is pretty good. Let me see. Is there a 4th edition? I am not seeing. I think 3rd edition might be the newest one still. I don't see one out for a 4th edition, so it's got to be a 3rd. I bought that book quite a while ago, but yeah, it's still, the concepts are still valid. Last one is 3rd, yeah. Okay, so we've recompiled. Let me just make sure I got rid of those validation errors, because that is super annoying. So load. Escape. Oh, dang it, what did I miss? The sampler, didn't I kill the sampler? Oh, these are the color map ones. So these are for the color maps. So I did acquire a new one for the terrain, it looks like. Wait a minute, why though? If we already have one. Was that meant to be... Was this meant to be... Default color map? It looks like I did that twice. Right, because I already have one here. Default color map and default terrain color map. This section might not even be needed. Wondering if I even need that. Let me see. Okay, that's slightly confusing. We're using the same... Oh. That's right. I'm technically using the same assignment. Okay. Let me rebuild this. I think I know what the problem is. I think it's because we have this weird situation where we're creating maps for all of the materials that come in. So let me run this guy. So we're technically creating one of these per material, I believe. Is what the issue is. So I think there's, you know what, let me look at the console text file. It might be a little easier to read. Okay, so there's 3. Oh, these are the depth textures. Are we not saving those off somewhere? I guess we're not. We killed the color ones, but not the depth. Not the depth ones for some reason. It was just the samplers. So we killed the textures, but not the samplers. Then what did we wind up using to bind this? these are the color maps. Did we do one earlier? No, that's just the shader load. Ooh, I need to check and see if this hack can be deleted too. Forgot about that. Mine globals. So when we set up the attachment, depth textures here. So this is where we create the writable texture. Where did we create the texture map for that though? I'm not actually seeing the creation of that anywhere, which is really strange. Oh, wait a minute. You know what? That's probably not even here. I wonder if that's in the material system. Okay. So this is for Shadow Map Pass 2048 to Depth Textures Text Map Sampler. I suppose I could search for that string. Actually, let's do depth texture. Shadow map, pass. I don't remember where I created the freaking sampler. So there's the texture. Wait a minute, wouldn't that be done by the render graph, actually? So, I wonder if we're not destroying an attachment. Let's load resources. Source textures. Attachment. Here it is right here. We're destroying this. Free internal memory, we don't want to do that. I am wondering if it's somewhere in here that's actually doing it. Search for border clamp since that's the only one that uses it. Yeah, I mean, maybe that's it. I think it's clamp border. Maybe not. Oh, clamp 2 border. So here's where we're creating the maps. There's 3 created, so I need to look for somewhere that's creating it per frame, which is why I'm thinking it might not actually be in here. Max material count. That's not what I'm looking for. Oh, wait a minute. This is probably it right here. That guy. Internal data shadow maps. This is where it's being done. So I need the... It was the scene pass. I was completely barking up the wrong tree. There we go. Okay, so I don't need all this crap. I need to release. I think that's a void, right? So and then this is going to be oh, I already have the internal data frame count. All right, I don't need these 2 things on. Okay. I don't need ext data. Okay. That should do it. And technically speaking, just do that. I'm pretty confident that's what it is. Okay, let's see. Only C, respect. Yep, only C. So far, anyways. Nothing says we can't build a C++ library on top of it if we wanted to, but why? Did you create it for Fong and forget to migrate it to PBR? No, I think I found it. I think this is it. So let's go ahead and run. In fact, that's something I have to do too, is I'm going to be removing Fong. You can't use it on terrains anyway, right? So There it is. We're done. Cool. So those are resolved. So I think what I'm going to do probably is I'm going to check this stuff in. I should probably do a diff on this real quick just to make sure that I'm not checking in anything stupid. Actually, yep, I know of something stupid I need to fix. Shadow map pass. Oops, I need the C file. Yeah, all this hack stuff I need to get out of here. And we need to make this a little bit more flexible, so we should probably go ahead and clean some of that stuff up. Defaulting to ortho viewport, point lights need perspective in an FOV. That hack I'm okay leaving there for now. I want to disable these and see if... because I was messing around with some winding stuff in here. And I don't think that that was ultimately an issue at all, but I want to verify that. Okay, I think I've got all that back the way that it was. That way I can get all these hacks out of there, because I've got a lot of like temp code and stuff that I had in there where I was experimenting with different things. I probably need to get all that cleaned up and moved out. Let's run. We'll just check our shaders, or our shadows really. See if they all look okay. They do so far. Yeah, so that looks pretty decent. Self-shadowing still working, so I think we're good there. Yeah. This is looking much better. Pretty happy with that. Okay, yeah, I'm pretty satisfied with that. We can remove that hack. All right. Okay. Let's see. To do, create projection matrix based on the extents of all visible shadow casting receiving objects. Okay, that's very much a to-do still. I think... read an... okay, so yeah, a configurable near and far clip would be good. Also, maybe a configurable range, like an area. Right, like we're kind of using this hard-coded area of 20 right now, which may or may not be what we want. So maybe we can add some configuration for that. So let's maybe go to... let's go here and just add some of this stuff. So we'll say F32 near clip and F32 far clip. And then for area, I guess we can say I think we could say rect 2D. Ortho bounds, I guess we could call it, or ortho. That should be fine. Rect 2D is floating point, right? Yes, okay. So we can use that instead of this area. And then I guess we can also say F32 FOV. just call this bounds, actually. FOV would be used for non-orthographic projection matrices, so configurability is always a good thing. Definitely don't want to skip on that. Render a projection matrix type. Yeah, we should definitely do that. So I guess let's put that here. Matrix type. Okay, and that allows us to switch most of this stuff, which is good. And that can basically be read directly in from configuration. So I think what we also might do, because right now we're just kind of like storing off the single property that we kept in here, which was resolution. But I'm thinking do away with that and keep a copy of the config instead. So we'll say shadow map pass config. And then in here, config is required, right? So shadow map pass create requires both a pointer to self and a valid config. All right, and then we'll just say self.config equals dereference config. Did I do that right? Nope. Oh, it's internal data. That needs to happen here. So self-config. Oh. I have to cast it first. That makes sense. Shadow map config. Pointer. And this is going to be self internal data config. There. Now we don't need to do this. And this is going to be config.resolution. And this will be the same thing. And same thing. Got a few of these throughout the code base, seems. Okay, I think I got them all. All right. Let me just catch up with the chat here. So yeah, if you guys have any questions, feel free to jump in. Right. For those of you who are new here, this is an interactive stream, right? So it's not just me coding. If you guys have questions, feel free to jump in and ask. Wretched Guac, welcome. Did you solve your problem from yesterday? Yes, I did. Yeah. So basically, let me build this real quick. Make sure I didn't bust anything. Typed config. Oh, right. Okay, I no longer need that one. No longer need that. Okay. I will run it for you and show you where we're at. All right, so here is this. We load up. All of our directional lights working. Our shadow map works. And so like we can come over here to this guy. Manipulate it, right? And the shadowing is working as we would expect. And we can rotate it. And everything looks pretty good, right? Self-shadowing included. And then if we go inside the Sponza, it suddenly looks drastically different with some better lighting applied, right? So we've also done some basic filtering on the shadow maps. So we've done some PCF filtering on it. So it looks a little bit better than just blocky, right? And we have ads. So we're going to pause here for 90 seconds and we'll be back just so that nobody misses anything. Also gives me a chance to hydrate, which you guys should do too as well. So, if you all haven't already, feel free to follow me here and over on YouTube, by the way, because we've got a lot more content than just what is here on stream, right? I've got the whole backlog of this series all on YouTube, so I would encourage you guys to follow over there. Oh, you redeemed to hydrate. Okay, I'll hydrate again. Thank you for that. All right, and ads are dead. So as I was saying, if you guys are new here, new to the stream, either here on Twitch or over on YouTube, I would encourage you to go ahead and toss a follow there, just so that you guys can see when I go live next, and don't miss any content. Right, my YouTube channel's got all kinds of content in addition to what we do here. So, yeah, if you haven't already, I would go ahead and follow there. I'm going to drop some social spam here in Twitch as well, just for you guys to be able to follow me in all the places. On YouTube, all those links are in my my profile. All right. So, we were in the process of making this a little bit more configurable. So we have a few of these things here that we need to add in examples for. And then we also need to go back and set these things up in the actual testbed application as well. So let's see, config. Right here. Okay. Past all this stuff, because I think we have all that sorted. Didn't we have... I could have swore that we had more. Maybe it was further down. Yeah, here we go. So these are all the things that we need to put in place. So what I'm going to do is transfer these settings over to here. So we'll say shadow map pass config. There it is. So in the application, we can now do shadow map config. That's annoyingly closely named. I'm going to rename that. Let's call this shadow pass config. Shadow pass config. We want to set the FOV to 0, which we don't necessarily have to do because we're doing this, but we'll be explicit here just with all the options. So bounds is going to be rect2d, and then we're going to do... Right now we kind of have this hard-coded to use this area, and then it's like negative area, area, negative area, area. So I'm going to say negative... You know what? I'm going to do the same thing here. F32 area equals 20. Negative area. So that's the bounds. That will essentially replace that. F32. Whoops. Shadow pass. Fig, rather. Near. We have that set to 1.0. And then far is set to, right now, 150. We'll probably wind up upping that at some point. Let's see, do we have any more options in there? I think that is, oh, matrix type is kind of important. So we want renderer, projection, matrix type, orthographic. Do we use orthographic or? Yeah, orthographic. Okay, so now we can use, we can configure it here instead of having to do that stuff in here. And then in here, I can say, let's see, let's get a pointer to config just to make this a little bit easier. So we'll say shadow map pass config equals internal data config, and we need the address of that. And now we can say config FOV, config near clip, config far clip. Whoops. There we go. And then I'm actually not going to pass the type in here because we're not using the viewport's created projection matrix. We actually need a different one than what the viewport creates. So we have notes about that here. So this is going to be, I guess it's going to wind up having to be config bounds x. I guess we can say, yeah, x. Oops. Config bounds y. Oh, this needs to be, yeah, those are already negated over there. Okay, so we'll just pass these through as is. Config bounds width, not to be confused with W. And then config bounds height. And then config near clip and config far clip. Okay, so we can do away with that. We can do away with, oops, what do we got here? That should be an arrow. That should be that. Okay. That makes sense. And that configuration is probably going to wind up changing once we have cascading shadow maps, by the way. All right, that is good enough for now, I think, on the configurability front. I don't think there's anything else in here that I need configurable at the moment. What other to-dos do we have in here? Read in properties for near far. Oh, we got that one. Oh, right. We're defaulting to an ortho viewport, which we don't necessarily need to do anymore. I'm going to leave that there because this technically is creating an ortho viewport, which may or may not be what we want to do. But what we need to change is this right here, the projection matrix. So if config matrix type equals projection matrix type orthographic, then we do that. Else internal data projection matrix equals mat for perspective. Config FOV aspect ratio is going to be, we're going to use the bounds for that. So config bounds dot width divided by config bounds height. And then this will just be config near clip. Config far clip. All right. So now we can at least have support for both of those types of projection. Okay. That was the other thing I wanted to swap out. This can go away. All right. I don't see anything else in here that's hacky. So I think we're good as far as that goes. Another thing I want to take a look at, actually, you know what? Before I change anything else, let's do a sanity build. Make sure we didn't break anything. All still looks pretty good. Cool beans. All right, so I want to take a look at the shaders themselves because there was some code in there that really could use cleaning up. So let's take a look at, I guess we'll do PBR first. We'll do the vertex shader, I suppose, first. I don't think there was much in here to clean up, but actually, I don't think there's anything in here to clean up. I don't think there's any... what was it? Trying to remember what the... what was it? Was it environment, maybe? Extension? I don't remember. I was trying to remember what the auto format was, but I can't remember the actual command off the top of my head, so whatever. Yeah, I think this looks pretty good. So let's look at the PBR fragment shader, because I know this had some stuff in it that needs to be cleaned up. Got some to-dos in there. I'm not going to worry about those just yet. Okay, so that's all fine. So So this stuff, actually, this is something else that probably should be configurable. So that maybe we can switch logic on this instead of, like, programmatically do it instead of commenting and uncommenting code, because that's kind of poopy, right? So maybe we should take in some additional values. So let me actually open up the vertex shader over here. So our global uniform has some space that we could add some stuff to it. So I'm thinking we might want a flag as to whether or not we want to run PCF. We also might want to pass in bias. Those are probably the first two things that we're going to want to do. Let's see, are there any other properties in here that we can expose? I don't think there are. So I guess we can use, we use an int for this, and we'll say use PCF. And then we'll also have a float bias. And then I'm going to add a vec2 padding here, just to round that out to 16 bytes. Okay. So I'm going to do this here. And then we can just transfer this stuff over in the DTO. Oh wait, is this in the, yeah. So we can put this stuff, I guess, right at the end, right? And then over here in the DTO, we'll put this stuff at the end. Not sure if I have to pad that or not. I might have to, I'm not sure. Then we can just create another small function here. So we say float PCF, I guess calculate PCF. And for that, what all do we need? I guess we need the projected depth. And we need the projected, actually we could just do projected, I guess. The projected coordinates. So we'll say vec3 projected. Take this, put it here. Also take this and put it up here. Let's see, shadow, texel size, PCF depth, projected depth. I can just say projected .z. Okay. And then our other option will be calculate unfiltered. So vec3 projected, I think, again, is the only thing that we need here. Oops. And for that one, we need this section. Right, projected depth is just projected.z. Still want to try this out too. Okay, so we don't actually even need this anymore. Now we can just say if in DTO use PCF, then return calculate PCF projected, else return calculate unfiltered projected. And I know technically we don't need the else here, right? So I guess we could get rid of that. There we go. So that's nice and clean now. Bias is now going to be, let's see, do we actually have, yeah, we have bias in here. So we can actually just say in dto.bias and in dto.bias. So we don't need this. All right, so that feels a lot cleaner. I do need to go over to the PBR shader config. And let's see, we added these under global. So we'll want to do that here after mode. All right, so instead of this, we're going to say use PCF. And then F32 global bias. And then vec2 global padding. And that just needs to be there in the shader. We don't actually have to hook that up in the material system. So now that we've got that there, let's go to the material system and hook it up over here. So we have apply global. So for our PBR, we have, oh, we need to get directions first, or locations rather. So we have render mode, use PCF, and then bias. We actually need initialize, where we set all these things. So let's see. State pointer, PBR, locations. Use PCF equals invalid U16. And then bias was the other one. Right. And then a little further down, when we actually load up the shader, we need to actually obtain those locations. So use PCF. This is going to be use PCF. And this will be bias. And so what we're doing right here is just getting the uniform locations and storing them off so that the material system knows where to actually insert these values in memory. So when we go to apply global, we can just access this. Let me move this up a little bit. So global shader options, right? So in this case, it's going to be PBR locations, use PCF. And right now we actually don't have anything to store this. So we're just going to leave that as is for a second. And I'm going to insert here bias. Right. And what I'm thinking for this is it might be nice to have this like hooked up in such a way where we can, well, let me think. I guess I could add like a kvar, right? We haven't used that system in a while because I believe that has support for integers and floats. Let's take a quick look. It's been a while since I've even looked at this system, but this is kind of a way that we have to store like global variables, right? Looks like we have a lot of stuff around ints, but we haven't actually filled this out for floats. Just kind of a disappointment. So I'll have to figure that out. Unstable failure. Thank you so much for the follow. I appreciate it. And welcome. Appreciate that. Okay, so I could do this technically for use PCF. But the bias, I'll have to hard code something for now. So let's do F32 bias equals 0, right? We're just going to use 0 anyways, so we're just going to say bias and leave it at that and say hack. Read this in from somewhere or have global setter question mark. So for the bias, that makes sense. Do we have, I don't think we have kvars here. We are not using kvars. So this was under engine core. So let's go ahead and add that. Let's see right here. Include core kvar. And what we're going to do is we're going to use this as a kvar. That way we can use like our command to set it in the console and instantly see it change. That is an amazing username, actually. That's really good. It's one of the better ones I've seen. Right. So, yeah, we'll just tie this into our console variable system for right now. I think that might be a kind of a cool thing to do. So when we initialize the material system, we'll go probably down towards the bottom of this, right? After we load all the shaders and all that stuff. Add a kvar to track PCF filtering enabled, disabled. All right, so we're going to say kvar int create, and we're going to call this use PCF, and the value we're going to set it to is going to be 1, so it's going to be on by default. On by default. Right? And then what we can do, for right now, we'll pull it every single time. But we should probably actually set up like an event to actually handle this for us. You know what? Let me do it that way, because that's pulling. It's going to be slow. So let's go up here to, let's see, let's pass all of our locations. Here we go, our system state. We'll add something to the bottom here. We'll say I32 use PCF. And the only reason we're storing this as an I32 is because it's stored as an integer in the console system, right? So we'll default that and initialize as well. In fact, we'll go ahead and just get it, right? So we'll say kvar int get use PCF, and we're going to use the address of state pointer use PCF, right? So we'll set it, and then we'll immediately get that value. That way we're in sync. Sleepy Mushroom, hello. That's also an amazing username. I like that one. How are you doing tonight? I hope you're doing well. All right. So let's see. I just want to look up one thing. I think it was all the way at the bottom of this. Kvar set int. Yeah, okay, so I'll need to remember that. All right, so we should, I believe, have an event for when a kvar gets set that we can subscribe to. This one right here. So, do we have... Do we actually have any events in here? No, we don't. Let's go to testbed main and just grab a example of an event. On event, yeah, this will work. Just because I don't feel like retyping this entire function signature. All right, so we'll put this towards the top, I think, because that's kind of what we seem to be doing with our event handlers. All right, and then we need to include. It's gonna go here, core event. Then we can fill this guy out. So we'll say static, so you don't need it outside of here. And we'll say on event. So we'll say, whoops, if code equals event code kvar changed. Then we're going to take a look at the event context and say if strings equal, we'll do a case insensitive, right? Say strings equal I. The first string will be use PCF, and the second one will be event context data. C, which is our character array, right? So we'll say if those two are equal, then we'll say state pointer use PCF equals context entry value. Did we actually pass the value, or did we just also pass the type? I guess we could just query it here, right? We could just say, okay, kvar, get that. We probably should pass it along with the event, but int get. And then this will be use PCF, and then we want the address of use PCF. Okay, so in this case, we want to return true because that event's been handled. We don't need anything else to handle that, I don't think. Otherwise, it's not been handled. All right. And then we can actually register for that event. So we'll go down here to the bottom of initialize, and we'll say event register. The code is going to be event code kvar changed. The listener, we don't really care, so we're just going to say 0. And then the event is going to be game on event. And I'm going to rename that here in a second. So let's rename this to material system on event. And then material system shutdown, we also need to stop listening for that event. So event unregister, event code kvar changed, no listener, material system on event. All right, so we have that, and now all we should need to do is actually hook up in the apply global function. Let's see, here's the PBR shader. We could say the address of state pointer use PCF. All right, and what this should allow us to do is to basically turn on and off PCF usage from the console. So let's build. Solieth, sorry this has nothing to do with the stream. I'm just not sure where else to ask. Do you have any good resources on rendering 2D games? All the graphics programming books I find are 3D only. So that's actually a really interesting question. One thing to bear in mind is that 2D and 3D are very similar in terms of how they actually function. You literally just don't use the Z-axis for 2D. All 2D rendering engines are the same, with that exception. The only difference being is whether or not you use a depth buffer, or whether you just render stuff on the screen in the order that's drawn, right? I'm trying to think of somewhere that, I mean, I don't know of any books or anything, but like you could study some 2D game engines out there to see how they work. But yeah, most of the stuff actually, like writing a 2D engine is generally much simpler than writing a 3D engine. So really you're just omitting the z-axis. That's the biggest part of it, right? I mean, there are all kinds of like 2D libraries out there that you could examine. You could take a look at SDL and see how that works. That's a good open source one. You could also take a look at like a 2D physics library like Box2D or something if you need physics. Yeah, I mean, I wrote a small WebGL powered 2D game engine on my YouTube channel. So that series is a few years old now, so you probably have to update parts of it to actually get it to run. But actually, that's like 5 or 6 years old, but it was written in TypeScript. So like that's another resource you could use. It's just something I've very basic I put together. Just a very basic 2D renderer. Pixie.js is another one. That's a library out there if you're looking for that. And anything that's WebGL, you can just pretty easily convert that to regular OpenGL, right? But yeah, most of the stuff that you're going to find probably is going to be 3D out there because 2D is really just a subset of that. I hope that makes sense. All right, so let's go ahead and run this. Oopsie. Structure must be qualified as flat N. Because we're using an int. Probably. Okay. So that's line 56. How am I going to... It wants to be a flat N probably because of it. Well, wait a minute. Why though? You know what? Instead of doing that, I'm just going to do what I did up here. I'm just going to create a new location for it. And say, use PCF. Delete it from there. Because that's just a DTO, right? Like it doesn't have to be there. And then over in the PBR frag, PBR vert rather. Instead of putting this here, I will do this. All right, so I'll change this to 2. Use PCF. Get rid of it out of here. I'll probably have to change this to... I'm going to change that to vector 3 just to be safe. All right. And then where I actually go to use it. Let's see. Oh, I wasn't even copying it over. That would have been confusing. So this is going to be whoops, out PCF. Whoops, out, wait. Use PCF equals global UBO use PCF. And then use PCF. Wherever I'm using that, it's just no longer part of that DTO. Okay. So hopefully, let's see. Overlapping use of location to, oh. Yep, that's right, actually. I did that backwards. This really should go up here, because each one of these things takes a location, or multiple locations, right? So this should actually be a 1, this should be a 2, and then we'll take this, put it up here, change this to a 1, and this to a 2. Keep accidentally dropping this behind the start menu, and it's super annoying. Okay. Oh, now what? 108. Boolean expression. Okay. Oh, that's got to be in the... Really? It can't figure that out? Okay, fine. All right. Now we're finally running. Okay, so if we go here, and I've only done this for the PBR shader, I'll have to go back and do it for the terrain shader as well. So we have PCF on right now. So if I type in kvar set int use PCF 0, it shuts it off. And if I turn it back to 1, it turns it back on. Right? So that's a great way to be able to test stuff like that, right? Very quickly. So we're planning on using the console a lot more for sure now that it's actually kind of in place and working properly. Let's see. Do you have any demo game ideas for the engine? Yes, I do. I have a few actually, and I'm having trouble picking one. So I'm probably going to just spitball it, or if I really can't decide, I might leave it up to the community. I haven't decided yet, but yeah, I have ideas. But yes, so we have that. Now again, it doesn't work for the terrain because I haven't hooked that up yet. So if I set that back to 0, notice it only affects the static mesh, right? So so basically everything that we've done in the PBR shader, we now need to translate over to the terrain shader. Config. So we'll do the shader config first. PBR shader config. Yep. And so we want these two in our globals. So let's see. In this case, yeah, I'm also going to put it right after mode for these two. So use PCF and bias, and then we'll go to terrain shader vert, and right here we're going to put int use PCF and float bias. All right. And then over in, let me just pull up the PBR shader vert. So we're literally going to use the same logic in both places. Oh, I didn't copy over the bias. So let's see, out dto.bias. This is global UBO bias. Need to make sure that gets copied over. So we need both of these things. And down here at the end, paste. And we need to do the same thing here. So we'll take this and paste that there, and then make this location 2. And that's it for that one. Terrain, frag, and PBR frag. And we're going to clean up this method just like we did on the other side. So we have, well, first thing we have to do is up here, right? So we have the global uniform object here as well, which I don't think, did we do that? Yeah, so it's, we have an int use PCF and float bias. All right. There's the instance uniform. And then we have this stuff, right? So we have, let's see. So we have our PCF there, and then we have our DTO here, which at the very end just has these guys. So we should be good on that front. And then actually I can just calculate, I could just copy this. And actually I think I can copy both of these, come to think of it. Yes, I can. So I can copy this and just replace that. And then the only other thing, oh, I forgot the calculate shadow bit. Still need that. That way the change down below doesn't actually have to, or the call down below doesn't actually have to change. All right, I think that's it for this. Just material system. So where we have made this change here, did we only do, yeah, we need these for our terrain shader. We can put that at the end here. And then we just need to have terrain locations right there. And our terrain locations don't actually have that yet, so we can go to definition on that, go to definition on this, terrain locations, and I'm actually just going to grab these from here and put them, I don't know, here at the end. Doesn't really matter for this. Okay. And I think that is it. So let's go ahead and build. And run. Oops. All right. What did we miss here? Oh, the vertex shader. 76. Okay. Terrain vertex shader. I can tell I'm starting to get tired. We don't want the shadow map one. We want that one. Okay. So it was saying, what was the error? Line 76. Out DTO.bias. Oh, we didn't add them here. So we need int use PCF and float bias. Okay. Now what did I miss? Location overlapping use of location 1. That's in the fragment shader, okay. I probably just forgot to change the label on that. Yep, I did. That should be a 2. Okay. So we'll load. Cool. My terrain isn't drawing. Sweet. So that likely indicates some sort of data alignment problem. Those are always fun. I was wondering if that was going to happen. So if we take a look at our... Did I do this on the... Let's see. PBR vert. On the DTO I put padding. Oh, I did put padding here. Why do I have a vector 2 though? Let me think about this. Yeah, because that one lines up with that. Yeah, I do need the vector 2 padding. Okay. So I need it there, and then I also need it in terrain frag. I already had it there. I don't have it. Wait, that's the DTO. Don't have it here. Okay, so maybe that was all that was wrong with it, I hope. Nope. All right, so this is 32 bytes. Those. That's strange. I wonder why that doesn't line up. Oh, alignment issues. They're always fun. You know what? I'm not going to guess at this. Let me just open it in RenderDoc and see what RenderDoc tells us. So if we go to render pass world, I think this is the terrain here. We go to pipeline states, vertex shader. We can take a look at the global UBO. Okay. So this is correct. The view position's correct. View. Okay, none of this stuff is... Well, it's at least not set, right? Do I have the padding in the shader config? I do not. Back to padding. Do I already have another one in here called padding? I'm pretty sure I do. Okay. Let's call this padding global. Sure. Let me just try running that again real quick and see if that actually solves the problem. Negative. So let's see. All of our data up until this point is actually getting set correctly. And this block even starts at 256, which is nicely aligned. So why is that not? I mean, this should work regardless, technically. It's providing 320 bytes, so it is aligning it that way too. This might be another issue for another night. I mean, we saw it working with the without this last change, right? Oh, wait a minute. Did we? I think I know what it might be. We didn't actually get valid locations for those uniforms, so we're probably like clobbering the projection. In fact, I'm pretty sure that's what's happening. Because look at these values; those aren't valid, right? I think we are not doing what we should be. For the terrain shader, we're not. That's the problem. All right, so this is terrain locations. Terrain locations. And actually, these two things need to come up here and be invalidated to begin with. Anyways, I would have made that easier to troubleshoot. Valid U16. Valid U16. All right. So I'm just going to try running this straight up. Let's post in render doc and see what we get. Yes, that was it. Okay, cool. So what we can do now is just verify that this works. So that we see that our PCF filtering is on for our shadows right now for both the car and in the terrain. We can see both of those things. So I'll say kvar, what was it, kvar set int? Yeah, kvar set int. Set int use PCF to 0. Bam, turns it off. And then if I go to set that back to 1, turns it back on. It's all dynamic. So that's a pretty nice way of getting that easily testable. And that, I think, is a fantastic point for us to leave it off for tonight. And in fact, I haven't checked in any of this logic yet or any of this code. So I think what I'm going to do is, I mean, I do need to review it I do need to take another couple passes at it, but I think it's making me a little nervous that it's just on this machine by itself and hasn't been pushed up to the repo yet. So I think I'm going to go ahead and do that. If I do get status on this, like, there's a lot of crap that's been changed. So git add commit. Implement. Oh, you know what? I forgot to update the. Hold on. Change log needs to be updated. Added shadow maps with PCF with optional PCF filtering. A kvar called use PCF can be toggled 0/1 to turn this on off. Okay, should probably make those match. Okay. Okay, and that's basically going to be my commit message too. Added shadow maps with optional PCF filtering and a kvar called use PCF that can be toggled on off 1 0 from the console. All right, and all of that stuff is now up on the repo, so if you guys want to take a look at it, it is now out there for you. So incidentally, the repo, I'll drop a link here in chat real quick. And I will drop the same link in YouTube chat. Apparently it can't be that long. Alright. So I'm just going to drop just the link then. There we go. Okay, so, yeah, that's where I'm going to leave it for tonight. And at least on the Twitch side, let's see. I think we're going to wind up... I think I'm going to raid Ferret Software tonight. So if you guys haven't already, follow me in all the places. The Twitter, you know, YouTube, Twitch, all that. The follows, likes, subscribes, all that stuff helps me out a lot when growing the channel and trying to get more exposure so that hopefully more people can learn from this stuff. The whole point of it is to be educational and an educational resource. So the more people I can reach, the better, I think. So if you guys can help me with that, I'd greatly appreciate it. Regardless, that is going to do it for tonight. So thank you guys so much for being here, hanging out with me, talking, and all that stuff. I really appreciate the support, guys, and we'll see you guys next time. For those of you on YouTube, I don't have a way to raid over there, but what I can do is I'll drop the link to where we're raiding. And so this is Ferret Software, and it is basically a ferret rescue that is run completely off the ad revenue of this channel. So just having the channel open is enough to provide the medical care, which is very expensive, and the food and everything that these ferrets need. And all of these ferrets were taken in from dire situations where they would have been put down otherwise. So it's a really good cause, and I highly believe in it, and I intend to keep supporting it. So Anyways, thank you guys for joining, and I will see you guys next time. See ya. Did the raid not go through? Really? Timed out, I guess. All right, 10 more seconds. Sorry about that, guys. Or maybe it's going to double raid. I'm not sure. All right, anyways, see ya.